Section 1.8 is an introduction to solving equations. I can solve equations using tables and mental math. Learning target and what we're shooting for here today. Big ideas here. Sometimes the value of one quantity can be found if the value of another is known. The relationship between the quantities can be represented in different ways, including tables, equations, and graphs. An equation is a mathematical sentence that uses an equal sign. We can use an equation to represent the relationship between two quantities that have the same value. On each side of our equal sign is going to be an expression, just like we've been dealing with so far this year. So the difference between an expression and an equation is the equal sign. Okay, expressions are just statements. They don't compare, whereas equations have an equal sign. They tell us one side equals the other. An equation is true if the expressions on each side of the equal sign are equal to each other. An equation is false if the expressions on either side of the equal sign are not equal. So if it makes a true statement, it's true. If it makes a false statement, it's false. An equation is an open sentence if it contains one or more variables and may be true or false depending on the value of its variables. In example 1 here, we're going to classify our equations to figure out if the equations are true, false, or open, and then explain. So you can either explain using words. You can say this equation is true because the expression on the left equals the expression on the right. Or you can show it mathematically. So here, we're going to simplify both our left side and our right side, our left expression and our right expression, and compare them. So 24 plus 18 gives me 42. That's completely simplified down to one number. And 20 plus 22 also equals 42. So since these are equal, it makes a true statement, which makes this equation true. In B, 7 times 8 is 56, and 54 is just 54. These two do not equal each other, so we do an equals with a slash through it. And since it is not true, we say it is false. It's not a true statement. 56 does not equal 54. And if we look at C here, we have a variable. And anytime we have a variable, it's open because we have an X. Open because of whatever our variable happens to be. Sometimes open equations are true if we plug in the right number. Other times they're false. And so we can't guarantee that it's true or false without knowing what variable or what value we're plugging in for the variable. So we just call them open. And again, as far as your explanation go, you can either write it out in sentence form. Because the left expression is 42 and the right expression simplifies to 42, which are equivalent, that makes this equation true. Or you can say 42 equals 42. Instead of saying the left expression is 56 while the right expression is 54, since those are not equal, this equation is false, you can just say 56 does not equal 54. But you do need to explain somehow. So whether it's mathematically or using sentences, that part doesn't matter to me, but there does need to be an explanation. Now, feel free to pause here and give these a try if you'd like. Is each equation true, false, or open? And explain. In A, I see variables. So anytime I see a variable, I know that it's open. And my explanation is because there's variables there, and my variable happens to be a y. Or you could say open because there's variables. Or you could circle them, point at them, however, that you can signify that you know that is the reason it's open. On B, we're going to simplify both expressions, both the left and the right side. 16 minus 7 gives me 9, and 4 plus 5 gives me 9. 9 does, in fact, equal 9. That's what we're looking for. So here, it's true. And the last one here, our left expression, 32 divided by 8, simplifies to 4. And our right expression, 2 times 3, simplifies to 6. Those are not equal. Since they're not equal, it makes a false equation, a false statement. A solution of an equation containing a variable is a value of the variable that makes the equation true. So if we can make it true with a value of the variable, that means that value is a solution. If it doesn't make it true, if it keeps it a false statement, then it is not a solution. So keep in mind, pay attention to what kind of question it's asking. In example 2, it's asking, is this a solution? That's a yes or no question. The last example is asked for true, false, and open. So just be careful there. To identify our solutions, if we look at our equation to start with, we know that it's open because it has the x. So sometimes it's going to be true, and sometimes it's going to be false. And the values that make it true are called our solutions. So here we want to check what happens if x is 6. Does that make it true or false? Is it a solution or not? So I'm going to take, and instead of having an x, I'm going to write in a 6. And keep in mind this 2x there is 2 times x. So 32 equals 2 times 6 plus 12. We're going to check and see, is that right? My left expression is just 32, but on the right I have 2 times 6, which is 12. And now PEMDAS says I can finally add, and I get 24 equals 32. And we know that that is not true. 24 does not equal 32. So since this is false, that means 6 is not a solution. The only solutions are the one that make the equation true. So is this a solution? No. And again, as far as your explanation, this over here works just fine for me. Now, for you to pause here and give this a try if you'd like, we want to know, is m equals 1/2 a solution of our equation? Well, instead of having an open statement here, I'm going to try and check and see if this is true or false. So instead of an m, I'm going to plug in a half. Keep in mind, 6m means we're multiplying. So 6 times a half minus 8 equals -5. And we're checking to see, is this right? When we multiply fractions, we have to have both fractions and then multiply straight across. So 6 times 1 is 6. 1 times 2 is 2. We can simplify that to be just 3. Bring down the rest of our problem. Now, 3 minus 8, when we subtract, we change it to adding the opposite. Here I have different signs, so I'm going to subtract and find the difference. Take my absolute values. 8 minus 3 gives me 5, and 8 is negative, so it's a -5. I get -5 equals -5, which is true. If it's true, then that means it is a solution. So is it a solution? Our answer here is yes, because it makes a true statement. Our answer is yes. In real-world problems, the word is can indicate equality. We can represent some real-world situations using an equation. So in example 3 here, we are going to use our cubes that's up on the bulletin board. Remember, C is for circle key numbers. U is for underline questions. B is for box any math words. E is for evaluate. Figure out what do we do, what steps. Evaluate. And S is for solve and check. So an art student wants to make a model of the Mayan Great Ball Court in Chichen Itza, Mexico. The length of the court is 2.4 times its width. The length of the student's model is 54 inches. What should the width of the model be? So I would suggest that you read through this first so that we know the situation, and then take it one sentence at a time. An art student wants to make a model of the Mayan Great Ball Court in Chichen Itza, Mexico. Do we have any key numbers? No. There's no questions we need to underline, and there's no math action words there to box or any mathy words to box. So this is just kind of setting up our scenario. We don't really need it. Nothing there is super important for us to solve this problem. So I'm just going to scribble through it, pretend like it's not there. It gives a lot of backstory, lets us know what we're doing. We're making a model of the Great Ball Court, but that's not helpful for us to actually solve this. The next sentence says the length of the court is 2.4 times its width. So here we're going to circle any key numbers, and we finally have a key number, 2.4. Then underline any questions or things it wants us to do. Here we don't have any. We're going to box any math words. So length is a math word. Is is a math word. We just talked about that. That means equals. Times means multiply. And width is a math word. Sometimes of can be, but here it's just part of a preposition. It's telling us more about the length, not anything about math. So we have everything important here. We have length is 2.4 times width. The next sentence says the length of the student's model is 54 inches. 54 inches is my key number. We don't have any questions. As far as math words go, I have length and is. We don't need anything else here. Again, that of doesn't matter. It's just part of a preposition. What should the width of the model be? Here I don't have any key numbers, but I do finally have a question. And if you want, you can underline the whole question, but I usually just like to underline the bulk of it, what it's really asking us for. And what it's really asking us for is width. Now, we can take this information and write it down. We have length is means equals 2.4 times means multiply width. Our next sentence says length is means equals 54 inches. And the third one tells us we're looking for the width. What is our width? That's our question. Here, I know I'm just going to look for W, which means I need to plug my L in to my equation. I know it's 54 inches equals 2.4 W. And eventually we're going to get to a point where we can solve this, but for now we're going to guess and check. So these are some 4 W values that we're going to check. And we can check those just by plugging them in for our W here, just like we did on the last slide. So when we plug in 2.4 times 2.4, we do not get 54, so A doesn't work. When I plug in 11.25 times 2.4, I do not get 54, so that one doesn't work. When I plug in 22.5, I finally get 54 equal to 54. So this checks. Since it makes a true statement, it means this is a solution. So how much should our width be? 22.5 inches. And we can check the last one just for good measure. It also does not work. Now we're going to do the same thing here. The length of the ball court in La Venta is 14 times the height of its walls. We're going to write an equation that can be used to find the height of a model that has a length of 49 centimeters. So, first sentence, the length of the ball court at La Venta is 14 times the height of its walls. Circle any key numbers. Then underline any questions or things it wants you to do or find. We don't have any of those here. Next are math words. Length of the ball court at La Venta is 14 times the height of its walls. The rest of that isn't important. Next sentence says, write an equation that can be used to find the height of a model that has a length of 49 centimeters. Circle key numbers. Underline the questions. We have 2 different things it wants us to do here. It wants us to write an equation, and it wants us to find the height. Now, any more math words that we need? I would say length here, and the rest we can get rid of. So now, sentence by sentence, we have length is 14 times height. Then we're looking to write an equation that can be used to find the height. So we're looking for height. We also know that length equals 49 centimeters. If we look, we have an equation here, but we need it to just be in terms of height. So I'm going to take my L and plug it in. And I get 49 equals 14 times H. And that's my equation. That's all the further we're taking this problem. I'm going to stop here and I'll finish this section in another video.